Hello all, so my name is Amanda, and in this video I'm going to explain about electrophoresis separation of nucleic acid. So do you guys know this picture, or does this picture looks weird for you? So basically this picture is an image of the separated DNA fragments on a piece of gel. And the process of separating them called electrophoresis separation technique. So electrophoresis is a technique to separate the different DNA fragments based on their size and reactivity. And this separation method is based on the movement of charged molecules when exposed in electrical field, and this process occurs in a gel medium. Since this separation method is based on the charge of the molecules, so what is DNA charge actually? So DNA is negatively charged because there is the phosphate group in the backbone of DNA double helix. Same with the DNA molecules, since not all fragments move at the same pace, so the small size will move quickly ahead while the bigger size will move slowly. So, when our DNA sample containing various size fragments is loaded onto the gel, then the charge applied across the gel helps in the mobility of these fragments. And if we see in the microscopic level of the mesh in the gel, we find that if different size DNA fragments are made to pass through these pores, it's obvious that the small-sized fragments will escape the pores quickly, while the larger fragments will find it difficult to come out. This is how we can understand the principle of this electrophoresis separation of DNA. So now let's get to the requirements for the procedure to work. The first one is casting tray, containing gel in which we will load the DNA sample, and next is the gel itself. Next is the comb for making wells in the gel. Next is electrical supply, and the last one is DNA sample with different size of DNA fragments. So this is the picture scheme of how we do the electrophoresis process. The first one, we have to make a well near the negative terminal or cathode with comb, as I mentioned before, so that since the DNA have negatively charged, so the DNA fragments will move forward from the negative electrode to positive electrode. And then we have to fill the apparatus with buffer to provide better conductivity of electricity, because the movement will be promoted by electric field. And since we can track the movement of DNA in the gel as it's colorless, so that's why we need color loading DNA to track the movement of the DNA. So after we load the DNA mixture to the well, then we have to turn on the power supply, and then we get the result. And after we get the result, now how do we detect the separated DNA? So we observe DNA molecule with treat agarose gel with ethyldiamide. We use ethyldiamide because it easily binds with the DNA molecules. And when the agarose gel containing DNA is observed on the UV light, so light orange colored band will appear, and that is called DNA bands. And how do we know the size of any DNA fragment? So to know that, we use DNA ladder so that we can identify the desired DNA. And that's all for my explanation. Thank you for watching.